Good morning all. I hope you can all hear me okay. I just wanted to introduce myself personally rather than the slide that comes up shortly. But first of all, thank you very much for joining us for this webinar in a series of ROBUS webinars. And today we're looking at LED rated light. I'll just give you a little bit of background to myself. I joined ROBUS in 2008, so coming up to 12 years service with them now. And I'm the product training manager, so I get involved in new products as they become launched, but also in new products as they're being developed as well. So it's quite important that we all have an input into the type of products that we bring to the market. So I hope you enjoy the webinar and take something away from it. And I'm going to close the camera now and get on with the webinar itself. So here we go, and I'll close that down. Okay. I've just introduced myself, and so we'll carry on with the next slide. And I just wanted to mention something that has been going very well for ROBUS, and that's the ROBUS Go loyalty app that we provide. And anybody that is registered on the ROBUS Go app will receive a further 200 points when you register any of the ROBUS webinars. To find out more about the ROBUS Go app, if you go to www.robusgo.com, you'll find more information about what you can do with those points. And they're very, very valuable. Okay, just a little bit about the really the housekeeping, or how to do a couple of things on the webinar if you've not used one of these before. So if you want to ask a question, you'll see in the top right hand corner there's an orange arrow. If you click on that to expand the control panel, you will then come up with the questions tab, which you can see there arrowed, and just below there you'll be able to ask a question, which we'll try and answer as many of them as we can in the time we've got allocated, but those that aren't answered will be answered via email personally to you. Okay, so what are we going to be covering today? First of all, we're going to have a small introduction about the topic. We're going to look very briefly at product development and how products are brought to the market. Then we're going to be going into the testing and verification that is employed in new products, with some third-party verification also. And then I'll have a look at some of the questions that you send in. So let's get started. So over the years, there has been a significant increase in the use of LED luminaires. Initially, there were no universal standards to measure or compare performance of LED lighting products. And whilst the quality and performance of LED technology has rapidly improved, application considerations have barely changed, and product data has remained unnecessarily complex to a user or somebody who's trying to look at the spec of a product. So there's often confusion about which LED luminaire to choose for a particular project and how to compare them side by side, so to speak. The main challenge for the professional market is to improve the way information is presented such that they're able to evaluate performance data of different manufacturers when preparing lighting projects or tender specifications. Unfortunately, sometimes unwittingly, apples are compared with pears instead of apples with apples. So specifically in this presentation, rated life is going to be discussed, and we're going to be looking at both initial and useful lifetime performance data, which must be evaluated in order to have confidence in the LED luminaires performance and how these characteristics will be sustained over the course of the luminaire's useful lifetime. So, how are products brought to market? How are they developed and brought into the marketplace? So, most suppliers, manufacturers use one or a combination of methods to bring new products to the marketplace. Each have their own arguments for and against introducing them in this particular way. So one of the ways that they can be brought to market is to design and develop a new product from scratch in-house. And there are some issues associated with that in terms of the time that it takes to bring a product to the market starting from scratch, the amount of testing that needs to be done, and you may have to start again at some point. The positive side of it is that you can bring a product to the market which nobody else has got, completely bespoke to yourselves. Or you can use an existing in-house product that has been developed previously and update it with the latest technology or aesthetically change it in some way. One of the most used methods of developing new products is to use partner manufacturers who have existing products very close to the specification that you require or that we require, which is already designed, developed and tested, i.e. you buy it and you sell it as it is. The good thing about that is that it obviously reduces the time to market and the physical initial testing that has to be carried out. The negative side of that is that some partner manufacturers will also sell to other suppliers in the UK market, so you don't have bespoke products. The fourth one is to use maybe the point 3, but tune the product's specification in some way, either for aesthetics, performance, or any USPs that you can try and build into or that you want to build into the product to make it more bespoke to yourselves. And that's the route that we often go down. So whichever method of product development route is chosen, it's really, really important that potential new products are tested and verified for safety and performance. And this is to confirm that partner supplier claims for individual parts or complete fittings are factual and verified by independent third-party lab tests and results. And they're going to provide a reliable product with minimal on-site issues, returns and other associated costs, which is going to increase customer confidence. So, testing and verification. This is an anatomy of a product of ours. It's an LED downlight, and we can see that there's lots of parts that go into making up the downlight. We've got the trim and springs and lots of different parts, including the LED, lens, driver, etc. And I'll just move on to the next slide here, which I've reduced the size of it down. And what we're saying here is that each constituent part of the system has a lifetime. So it could be, as we're looking at today, that the LED has got a specific rated life, and we can look at ways that we prove that. The driver will have, even things like the springs that hold it in the ceiling are going to have a rated life. because over time they may start to weaken, so that the fitting starts to droop out the ceiling a little bit. The trim, whether it yellows over time because of any UV or heat that is generated. So all the component parts interact, and one has an effect on the other very often. And the lifetime, or the individual lifetimes of all these system parts, have a bearing on what the warranty is for the complete product. Some specific considerations associated with the rated LED life is importantly LED junction temperature. So that is the temperature within the chip, the actual LED chip, where the photons are generated, the PM junction as we call it. And it's really important that the temperature at that point doesn't increase past what the manufacturer recommends for it. And similarly, the product or the LED should be driven at the right current, so they're not overstressed, driven too hard, and start to get hot, so the junction temperature increases and it causes a problem for the life of the product. Also, we have to look at heat sinking, whether it's passive, as a passive heat sink, or active cooling, where maybe we have a fan to keep the product or the internal component parts of it cooler. We also have to look at the luminaire design, whether it's IP20 or whether it's IP65, because this is going to have a bearing on the heat that's inside the product. It's a lot easier for it to dissipate from the IP20 product compared to a very well sealed IP65 product. So this is important too. And the luminaire application is important, whether it's going to be used internally or externally, or in a special environment, a special location, maybe such as swimming pools, etc. Those sort of areas. Okay, so before the advent of any recognized test procedures, LED component manufacturers each reported lumen maintenance data using their own disparate, different and varied methods and systems. This often led to the luminaire manufacturers who use these LED components making slightly unrealistic claims of performance and life expectancy. To make some sense of this new lighting technology, LED, IES LM-80, that's the Illumination Engineering Society of North America, introduced two new standards: LM-80, which is a standard method for testing LEDs for initial luminous flux, and depreciation over a meaningful test period. They also introduced the standard TM21, which is a method of extrapolating the testing values of LM-80 for a predicted luminous flux at an effective end of useful lifetime. So IES LM-80. Following the release of the original LM-80 standard in 2008, the LM-80 working group released two additional updates, LM-80-08 and -15. And -15 expanded the standard to include radiant, photon and luminous flux maintenance. So what is LM-80? It's a method for measuring LED light source, the LED light source at various temperatures, and they're stipulated at 55 degrees, 85 degrees, and optionally at another manufacturer selected temperature, maybe 105 degrees, it does vary. It also specifies a minimum testing period of 6,000 hours, with 10,000 hours being the preferred testing period. It also requires testing and results taken at a minimum of 1,000 hour increments. And this is a typical LM-80 table that is generated. This one is for data set at 55 degrees C with 150 milliamp drive current. And we can see here, and I'll use my cursor if it's, hopefully you can see it, that on the left-hand side, we've got a sample number of LEDs. In this case, it's 25. It also shows the forward voltage for each of those LEDs, around about 3.2 volts. And it also shows the luminous flux at 0 hours. So this is the initial luminous flux when they're first powered up. And then in 1,000 hour increments, it looks at the luminous flux and measures it as a percentage of what it starts at. So after 1,000 hours, LED number 1 was 101% of its initial 0 hour flux, which was 68.96 lumens. And we can see that initially it is a little bit higher than 100%, but then it starts to just degrade slightly over these measured hours. So that happens for a number of hours. 6 to 10,000 hours is the 6,000 or 10,000 hours is the preferred testing period. And we can see that in this particular case, after 10,000 hours, this LED was 96.2% of what it started out at. So that's a typical LM-80 data table, which is generated as part of a third-party independent test of the LEDs themselves. There's other information at the bottom here where we look at averages of some of those figures. Okay, so the second standard that we spoke about earlier was IES TM21. And while LM-80 provides a standard method for testing lumen maintenance, it doesn't provide guidance for predicting beyond the duration of these measurements, which is quite a long time, 10,000 hours, but it certainly doesn't make any guidance for recommendation of lumen maintenance over a longer period. So this was addressed in 2011 when the IES published TM21, which was a method for projecting the lumen degradation beyond the LM-80 test period. So TM21 is a current method for projecting useful LED product life at realistic operating temperatures. When we say realistic, we mean those that the product would incur during its normal operation. Once LM-80 test is complete, the resultant measurements are used to determine a depreciation curve for the luminous flux at each tested temperature. So that's 55, 85, and a third manufacturer nominated test temperature. The data is used as described in TM21 to determine the L70, L80, or L90. In fact, any percentage of lumen maintenance life projection. So looking at that, LM-80 is a physical testing procedure, and TM21 is a calculation procedure which uses that test data and extrapolates it to a longer period of time using a trend curve of light output depreciation. So TM21 data provide projected long-term lumen maintenance. It requires LM-80 test data. It requires initial luminous flux that it can start to look at the degradation, and it needs the percentage depreciation in 1 hour intervals, 1,000 hour intervals. In terms of the sample size, you saw from the LM-80 data report that there were 25 samples that were tested there, and they do stipulate that If there's below 20 samples, the information can only be extrapolated to 5.5 times the test duration. So if it was 10,000 hours test duration, 5.5, so 55,000 hours would be the maximum. If it's greater than 20 samples, then we can extrapolate to 6 times. 6 times 10,000 hours is 60,000 hours. So reported hours are based on extrapolation to either 5.5 or 6 times the tested duration. This is a typical result of TM21. And if we look at the yellow section, this is the information that needs to be input by the tester or the test house. And it's about the LED itself, what type it is, what manufacturer it is, the number of units tested, and we can see here that there was 25 tested in the LM-80 report. There were no failures. The number of units measured was the full amount, 25. Test duration of the LM-80 information was 10,000 hours with 150 milliamp drive current, and the test case temperature, i.e. the LED case temperature, was 55, 85 and 105 degrees. And that information sits over here. So that is the complete test data for the 3 temperatures over 10,000 hours up to 1,000 with 1,000 hour increments. Then we need to actually put some physical data into the TM21 report. We also need to put the actual current for each LED package or array that's being tested. So in the test LM-80, it was 150 milliamps. When it's actually put into the product and tested, the actual drive current was 130 milliamps. And it's important for TM21 to have actual physical data of the complete luminaire. So 130 milliamps. The in situ case temperature of the LED was 75.8. So that's very, very precise. It wasn't 55, it wasn't 85, it wasn't 105, it was 75.8 degrees when measured. And we also have the opportunity then of putting in the percentage of the initial lumens that we want to project to. I.e. for L70, we put 70 in there. For L80, we put 80 in there. So that's the percentage of initial lumens that we want to project, and the hours that it will give that 70% to in this case. We're suggesting that we'd like to estimate the lumen maintenance over 50,000 hours. And the calculation that he's done is that in the blue areas, so it's showing that the lumen maintenance at time T, which is 50,000 hours, was 79.42%. This is using the LM21 TM21 calculation. And the reported L70 hours, i.e. what if we could actually report if we wanted to, would have been greater than 60,000 hours for this particular product. What do we mean by in situ temperature measurement, IST-MT? So it's the measurement of the LED source case temperature within the LED system, the luminaire or the lamp, while it's operating in its designed position or environment, i.e. in the situation that it's going to be used in. The measurement is performed at the temperature measurement point, the TC point, that's indicated by the LED package manufacturer. We can't obviously put a temperature probe onto the PN junction within the LED itself, but the LED manufacturer will give instructions as to where the nearest point is that you can accurately measure the LED junction temperature. So thermocouples are attached to these points to the LED in the installed luminaire with its diffuser and lens and everything else in its normal operating environment at 25 degrees C. And 3 tests are conducted to give accurate measurement. So you can see there's 3 LEDs there, and they have got the the probes attached to them in order to measure that junction temperature. The LED driver TC point is also measured, and that's measured at the point on the driver that the driver manufacturer, whoever that might be, suggests is the ideal place to measure that temperature. And then from that, we get the TM21 report. So this is each of the LM-80 test conditions, so at 55 degree case temperature, at 85 degree case temperature, and 105 degree case temperature. And on the right hand side here, we've got the interpolation part of the report, which has got information about the 55 degree and 85 degree. If we remember, the actual temperature of the LED when it was measured in situ was 75.8 degrees. So we refer to the information from the 55 degree and 85 degree junction temperature data, and it then pulls out the reported L70 hours at 75.8 degrees C. So this is the real product in its operating conditions, and it's reporting that we will get greater than 60,000 hours from that product at 70% of its initial lumen output. So some other third-party verification. The IES also brought in a standard, LM-79, which utilizes a number of other standards to prepare an electrical and photometric test report. And all of those standards, I'm not going to go through them, but there's lots of different standards there that it refers to. And this is the information that the report will contain. So it's got the Insitu measurements, LM-80 measurements, and TM21 measurements in the report, but it's got the initial lumen output, the total lumen output, beam angle, efficacy, all of these different parameters, both electrical and photometric. And this comes out as part of a total report from the third-party test house that prepares this test procedure, both the LM-80, the TM21, and the LM-79 reports. An alternative method of measurement is using EN 62722-2.1, which is the Luminaire standard in Europe. It is promoted by Lighting Europe, and it will be employed in the single lighting regulation, which is effective and comes into force in September of next year, 2021, and it encompasses full system light testing. But if we look at the parameters there that it actually covers in the report, they're all very, very similar to the LM-79 report, and they're both based on the same type of information. Okay, if we just finish up now with this this last slide, and this is about whole system life rating and warranty. It goes back to one of the initial slides where we have every component part of the product itself, the luminaire. So the system or luminaire warranty based on all component life. So that's the LED rated life, the driver rated life, the lens, diffuser, light guide plate, the housing. All of these component parts go into producing a warranty for these components. So a reputable supplier, in order to back all this information up, will make test report data available for inspection. So it's quite important when we're looking at products to use in a project, in a specification, that we're confident that the product is going to do what people are claiming it does. And the only real way of doing that is to see test reports where it's gone through a number of test procedures in order to verify those claims. And at ROBUS, we're able to produce those for any of the products we bring to the market. So I'll have a look at any questions now. See what we've got. Okay. Right, I've got a couple of questions here that I'll answer, and any others that come in afterwards, they will be answered subsequently and directly to your individual email addresses for those that have asked them. And the first question that I've got is IST empty, so in situ measurement and TM21 data from a manufacturer that is not supplied from a third-party test lab acceptable? So there, if we look at a supplier to us that provides TM21 data and it's not from a third-party test lab, is it acceptable? Well, the answer to that is no. From our perspective, it certainly isn't. All reputable partner suppliers that we use will independently verify their own initial test with a third-party independent test and the results from that. The reasons is that obviously they need to ascertain that the correct methodology has been used for the tests. Calibrated equipment is also used, and it's tested in the right conditions, i.e. the ambient temperature is correct at 25 degrees and it's in the specified conditions. So hopefully that answers that question. Let's have a look at what else have we got. Would the rated life of LEDs in an IP20 fitting be longer than an IP67 fitting? Okay, so if we think about that, if we've got the same LED, the same manufacturer, the same type of LED in an IP20 fitting as we have in an IP67 fitting, the likelihood is that the junction temperature of the LEDs in the IP67 fitting would be probably slightly higher than the IP20, so it could make a difference to the rated life. The calculated rated life is going to be based on this junction temperature, and that would need to be measured in situ to give the right temperature and drive current to get the predicted life of that particular product, whether it be an IP20 fitting or an IP67 fitting. And the reality is that if the junction temperature in the IP67 fitting went above what it should be, then the reported or predicted life of that LED would be reduced if you were looking to measure it to L70, and rather than 50,000 hours, it might only give that 70% light output up to 25,000 hours. So it could reduce the life of the product in which case you may say we need to change the LEDs for a different type that is going to operate at a slightly higher temperature. Okay, let's have a look at another one. How accurate is the TM21 extrapolation process, as there is only a short period of physical testing during this process? And that's a good point, to be fair. And what I'd sort of say to that is, since the introduction of TM21 in 2011, it's been the sort of the method, the de facto method, default method of predicting useful life. So that's for nearly 10 years. And it's certainly proved to be a robust method of predicting life over that period of time. It's not that it's been found that maybe it's been way out and over predicted the lifetimes from this process. They're pretty accurate, and to be honest, I think they're a little bit conservative, and certainly manufacturers like ourselves and lots of manufacturers do this, although the life that is calculated might well be, say, 60,000 hours. We always tend to pull it back a little bit and we'll quote maybe 50,000 hours for that particular product. Okay, there's lots of questions there which I'm not going to get round to answering due to time. So all of those questions that I've got there, I will answer those and email you each directly with those. So it leads me to say, really, thanks very, very much for your attendance, the time that you've put into it, and hopefully you'll join us again on one of our other webinars. And please feel free to contact us on our website, and you'll find all the contact details of both myself and our technical department if you need to know anything about this subject or any other subject or technical issue that you want to discuss with us. So it leads me to say thanks very much for your time, and stay safe, and hopefully we'll all get back to a more normal working life in due course. So thanks very much, and bye for now, and all the very best.